unveiling the genius Johannes Kepler, an ardent stargazer and a key figure in the 17th century scientific revolution. The stage of our story is set in a time when the horizons of human understanding were expanding rapidly, a period of profound change and reinvention. It was the 17th century, a time painted by the broad strokes of the scientific revolution. The canvas of this revolution was adorned by many great minds, but among them a particular figure stood out: Johannes Kepler. Born in the serene town of Weil der Stadt in southwest Germany, Kepler's curiosity about the cosmos was kindled from an early age. The son of a mercenary and an innkeeper's daughter, his early life was fraught with adversity. Despite the hurdles, the light of learning was never extinguished within him. Kepler pursued his studies at the University of Tübingen. There, he was introduced to the heliocentric Copernican model of the solar system, which placed the sun at the center. This piqued his interest and he began studying planetary motion in earnest. His first breakthrough came with the publication of Mysterium Cosmographicum in 1596. Here, Kepler proposed that the distances of the planets from the Sun were determined by the shapes of the 5 Platonic solids. Although this theory was later proven incorrect, it kick-started his journey towards unearthing the hidden mechanisms of our cosmos. In the years that followed, Kepler's work was hallmarked by his unparalleled attention to detail. He pored over the observational data of his time, meticulously recording his findings and theories. His dedication led to the development of his 3 laws of planetary motion. The first law, published in 1609, stated that planets move around the Sun in elliptical, not circular orbits. This directly contradicted the prevailing belief of perfect circular planetary paths. Kepler's second law, also presented in 1609, proposed that a line connecting a planet and the Sun would sweep out equal areas. His third and final law, revealed in 1619, demonstrated the relationship between the time it takes a planet to orbit the Sun and its average distance from the Sun. Kepler's laws of planetary motion were revolutionary. They not only provided a more accurate description of the planet's movements, but also set the stage for Sir Isaac Newton's laws of motion and universal gravitation. Despite being over 4 centuries old, these laws remain relevant in the field of astronomy today. Kepler's contribution to astronomy was not confined to his laws of planetary motion. He also made significant strides in the field of optics, paving the way for improvements in telescope design. His work on understanding light and vision was truly ahead of its time and continues to influence modern optical physics. It is nearly impossible to quantify the impact Kepler has had on our understanding of the universe. His unwavering curiosity, his meticulous approach, and his relentless pursuit of truth have made him a beacon of scientific inquiry. He embodies the spirit of the scientific revolution, a time when mankind dared to question the status quo and venture into the unknown. His laws of planetary motion, still relevant, etching the path of astronomy.